Hello everyone. In this video, we're going to be looking at an interesting problem, which is an equation in split complex number world. Now, we talked about complex numbers in this channel as well as a plus bi. In case you didn't know, I have a channel dedicated to complex numbers. And here's what it's called. Easy to remember because that's how you write a complex number, right? A plus bi. And then we talked about dual numbers recently because remember, Black Pen, Red Pen made a video and then I had a video response, which I didn't really hear any response to, but anyways, that's okay. And then now we are going to be doing another interesting problem from an interesting world, which is called the split complex numbers. So we're going to go ahead and start by the definition. And I know some of you are probably thinking, wait a minute, isn't this like a quadratic equation, like a polynomial equation, so it only has two solutions? Well, this is a different world, so let's go ahead and find out. Okay, great. Now, where does this problem come from? This problem was suggested by one of my viewers. Thank you, Oren Feifel. I hope I read it right. This was a great suggestion. I love it. Please keep them coming. I really look at the comments. I read them and try to respond as much as I can. And your suggestions are always appreciated. So, split complex numbers can be defined as numbers like a plus bj, where a and b are real numbers, and j squared happens to be 1. Now, compare this to complex numbers where you have a plus bi, where I squared is equal to -1. And of course, a and b also have to be real numbers. Of course, we're not saying j is 1 or -1, but it's a weird number whose square is 1, but itself is just j. J is j, okay? So we're going to be doing some equation solving, and I'm planning to continue based on how much interest I'm going to be gathering from here. We'll see how that goes, and I'll let you know. So, in general, we define a split complex number as a plus bj, where a and b are real numbers. Now, how do we solve this equation? We have z squared minus 4z plus 3 equals 0. And I can kind of hear what you're saying. You're probably thinking, okay, no big deal, just factor it and boom, you get two solutions. But guess what? By doing this, you're assuming that z belongs to the world of real numbers, not a split complex number. So and at the end, we're going to check our work and you're going to see that there are actually solutions besides these. So how come that's possible, right? Let's go ahead and explore that. It's going to be pretty interesting. So here's what we're going to do. Since z is a split complex number, we're going to replace z with a plus bj, okay? Just like we solve any other equation with complex numbers, a lot of times we do that with a plus bi, right? So let's go ahead and replace z with a plus bj. Remember that j squared is equal to 1. That's pretty much the only thing you need to remember, okay? Let's go ahead and plug it in. And guess what this is going to turn into? Now, when we square this, it's going to give us a squared plus 2abj plus b squared j squared. And then minus 4a minus 4bj plus 3 is equal to 0. Obviously, you're going to get a more complicated result from here. But remember, j squared is equal to positive 1. So this is 1. What is j? J is j. So keep it like that. So once that turns into 1, we're going to get the real part, which is a squared plus b squared minus 4a plus 3. And the split complex part is just going to be made up of this one and this one. So we're going to get 2ab minus 4b multiplied by j, and the whole thing is equal to 0. Great. How can a split complex number be 0, right? Well, it's real part and in split complex part, both have to equal 0. So from here, you get two equations. You get a system of equations, just like complex numbers. But this time, and of course every time, you got to remember that a and b are real. If they're not real, then we don't accept them. Let's start with this one because that seems easier. 2ab minus 4b equals 0. Now, don't make a mistake of adding 4b and then canceling out the b's because you'll definitely need the b's, okay? Now, I'm going to factor out a 2b, or not 2b, right? I always make that cheap joke. Minus 2 equals 0. And you can divide both sides by 4, no big deal. By the way, I think I made a mistake, didn't I? So 2b multiplied by a, of course. From here we get two things, right? One of them is b equals 0. The other one is a equals 2. So that kind of splits our equation into two pieces. And of course we have to check both. Okay, that's what makes this problem very interesting. Now, let's start with b equals 0. What happens if b is equal to 0, right? Well, we have to go to the other equation, a squared plus b squared minus 4a plus 3. If b is equal to 0, that's just going to disappear. And we're going to end up with this, a squared minus 4a plus 3 equals 0. Does that look familiar? Yes, it is actually the same equation we started with, but this time a is a real number, so we're going to get two real solutions, a equals 1 and a equals 3. Now, you got to remember, a equals 1 if b equals 0, a equals 3 if b equals 0. So what does that give us? That gives us two solutions, and remember our solutions are in the form of a plus bj. But let me go on and finish this whole thing, and then I'm going to go ahead and write all of the solutions at the same time, okay? So what happens if a is equal to 2? That's our second case. Now, if a is equal to 2, obviously you're going to plug it in again in this first equation, which is a squared plus b squared minus 4a plus 3 equals 0. Now, if a is equal to 2, you need to replace a with 2. 4 plus b squared is going to stay. 4 times a is going to be 8 plus 3 equals 0. 4 plus 3 is 7. 7 minus 8, negative 1. So from here we get b squared minus 1 is equal to 0. As you know, this is factorable into difference of two squares, or you can add 1 to both sides, square both sides. Absolute values, so on and so forth. To keep a long story short, you get two b values, 1 and negative 1. But again, these are the values we get if a is equal to 2. Remember the if statement. Now let's go ahead and put it all together and write all the solutions to this split complex equation. Are you ready? Okay, great. Now we know that if b is 0, a is 1, which means our number z is going to be like a plus bj, so it's going to be 1 plus 0j, right? That's one of the solutions. So we don't need to write z because we know all of them are z. And then the second case is if a is 3, b is 0, which means 3 plus 0j. And then if a is equal to 2, b is equal to 1, that gives us 2 plus j. A is 2, b equals negative 1 gives us 2 minus j. Wow. This equation has actually 4 solutions, okay? These are all the solutions. You can also write them in a solution set, blah, blah, blah. Same idea. But as you can see, even though this equation is quadratic, it has 4 solutions. Why? Because of the component-wise solution. It has 2 components, and that kind of produces more equations, gives you a system, and you kind of get this interesting scenario. Okay? Now, here's what we're going to do. Obviously, I'm sure that you will agree that 1 and 3 are valid solutions. By the way, I forgot to say that 0j doesn't really mean anything. It just means that solutions are 1, 3. So let's go ahead and list them, actually. I think that they're going to look better on a list. So all the solutions are like this. 1 and 3 are kind of obvious, aren't they? Because we know that they are real. They're not, they are just real, right? And they definitely satisfy. What about 2 plus j? You can plug it in, right? Definitely, and it'll work. Let's test it out. 2 plus j squared minus 4 times 2 plus j plus 3. This is going to be 4 plus 4j plus j squared. And then minus 8 minus 4j plus 3. And then here, we know that j squared is equal to 1. 4 plus 1 is 5. 5 plus 3 is 8. These numbers all cancel out. 4j cancels out. We end up with 0. And yay, they do actually work. And 2 minus j will work the same way. But what happens if you take these two solutions and multiply them together? Something interesting happens, 2 plus j. And by the way, they're conjugates, right? So when you multiply them from difference of 2 squares, you're going to get 4 minus j squared, and the product of the roots will be 3. Now, if you think about Vieta's formulas, we do know that in a polynomial, the product of the two roots will always give you c over a, and yes, it's verified, but not by all the product, because this equation is weird. It has 4 solutions. And in another video, we're going to dig deeper into split complex numbers. I hope this video was liked and commented by you. Anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out SyberMath, aplusbi, and until next time, bye-bye.